Assalamualaikum Miss, I am Nur Zatagai Mamiti Ahmad from EH1104A and I am going to present on the prelab of liquid. So next, is the theory of the experiment. Liquid extraction is the selective removal of one or more components either from a homogeneous liquid mixture or from a solution by using a second liquid or solvent which is partially or wholly immiscible with the first one. Fed solutions are mixed with solvent through agitation to extract the solution from the solid from the solution, which then exit as an extract. Extract are called. I am going to explain on the objective of the experiment. First is to operate a liquid extraction experiment by using a rotating disc column. Next, to determine the high equilibrium theoretical plates, which is HETP from the column. And lastly, the objective is to investigate the effect of the solvent to feed flow rate ratios and rotating this speed on the HETP. So next, this is the process flow diagram of the liquid extraction. B1 and B2 are the feed vessel. K1 is the rotating disc column. P1 and P2 are the dosing pump. B3 and B4 are the receiving vessel. B5 and B6 are the pulsation dampers, and the last one is the rotating disc stirrer. So now I am going to proceed on the procedure of the experiment. First, ensure that all equilibrium and calibration data are obtained through Appendix D. Second, perform the general startup procedure. Third, start both pump 1 and pump 2 and set the desired feed and solvent flow rates by adjusting the pump's frequency and displacement. Next, allow the both liquid to flow into the collection vessel, which are B3 that is raffinate and B4 that is extract respectively. The bottom product contains the water-rich phase raffinate, while the top product contains the toluene-rich phase, which is the extract. Next, monitor the interface level. Next, monitor the interface level. Maintain it at about 100 cm above the solvent inlet by adjusting the height of the overflow tube. Next, once then both collection vessels, which are B3 and B4, are filled with sample products, start to collect the sample. Next, open valve HV17 to collect the sample of raffinate and open valve HV15 to collect the sample of extract. Next, start the stopwatch and continue to collect the product sample at every 2, 4, 6 minutes until the refractive index value are constant. Next, record the refractive index value of both samples until constant and use the calibration curve in Appendix D to determine the acetone, which are the solute composition in each phase. Next, record all that data in the sample table provided in Appendix A. Next, stop both pump 1 and pump 2. Last but not least, repeat the experiment from step 3 to step 10 by turning on the rotating disc stirrer and set the stirrer speed at 250 rpm, but fix the same flow rate and feed composition throughout the whole experiment. So now I am going to sit with how to collect the data. First, we can collect the data of refractive index from the refractometer. Next, the sample can be collected from valve 17, which is the raffinate, and valve 15, which is the extract. So So now I am going to explain on the missing data and how to obtain it. On the theoretical stages, we can refer to Appendix B. On high equivalent theoretical plates, which is HETP, we can use the formula that is provided. On the composition, we also can use the formula. And also the last one is for the efficiency. We can use the formula provided in the lab manual. So now this is the formula for the experiment. First, HETP can be calculated by dividing effective column height by the number of theoretical plates. Next, effective column height is equal to height of the column times the number of actual stages. The composition can be calculated by dividing moles of A by the total moles. Efficiency can be calculated by dividing amount of extracted solid by the amount of solid in feed and then times with 100%. The data also can be calculated by using the provided Appendix B. Okay, the last one is the expected result of the whole experiment. I expect that the separation of the mixture through the liquid-liquid extraction process will reach the desired condition and concentration. It then will increases the number of theoretical stages, which will produces lower HETP. Thus, it will make the extraction become more effective and efficient in separating mixture in larger amount. That's all from me. Thank you.